I'm just going to start now with session 2. So my name's Zina Farouk. Firstly, I forgot to introduce myself. I'm our application specialist and geotechnical engineer with Arab. The objectives of session 2 today are to introduce the assessment methodology in XDisp for buildings, utilities, and rail damage. I'm also going to discuss one or two advanced features. So I'm going to treat you with a quick demo of how XDisp works with PDisp, but I'm also going to show you one or two other features as well. The previous webinar covered how you would calculate settlement with XDisp, how you would input tunnel and embedded excavations and walls, and it went into more detail about the basic theory behind XDisp. A recording's available on our website, so please do look at it later if you missed it and you want to go through that. I'm going to set up an analysis live for you as well, so that will be interesting and hopefully help you understand the feature much better. And as I go through the setup, I'm going to go through some of the shortcuts and tips with you too. And at the end, we will discuss how you would go about getting more support and, if you don't have the software, how you can get it. So just a brief summary of XDisp, and sorry if you attended session 1 because I am covering a little bit again. But XDisp calculates ground movements due to excavations, typically tunneling excavations, shafts and retain cuts, and it can also assess mined excavations too. So it will output building, utility and rail damage assessments based on your inputs for the tunnels and the excavations. You also have to tell XDisp where you want calculations to happen. So you have to input in grids and lines as well, but that was covered in much more detail in session 1. But what I'm going to go through today is the kind of displacement outputs and the building damage interactions and utility damage assessments as well. So let's start now with the base theory before I go into the program in much more detail. So we're going to do building damage assessments first. So what is building damage is the first question. It is a highly emotive subject. We have a number of case studies, for example, for building damage, but a lot of clients and our customers are not able to share those case studies because it is often a sensitive subject. A lot of people don't want to talk about it in more detail, but it is important to assess and it's critical for a lot of major city projects, or if you're working near a very important building. So in terms of categories of damage, how we assess damage, um, there are an increasing there's kind of an increasing scale of severity of damage based on the foundation movement. And this is where XDisp comes into its own, because it will tell you the settlement at the base of your foundation, and then it will go on to calculate building strain. So it starts off with lesser movement, which causes a change in visual appearance and aesthetics. Then it goes on to serviceability or function. So, for example, you might start seeing cracking, significant cracking in the building. And then, with severe damage, you've got the stability of the building at stake. So the most commonly used system, which we're going to really explain in much more detail in this presentation, is the Berland category of damage, and that's incorporated into XDisp. But if you are using another system of damage, you can input that in yourself in XDisp. The program allows you to do that. So I'll just go through the Berland categories of damage because that seems to be used by most of our clients and customers. So negligible to slight, so 0 to 2 as categories of damage, affect the visual appearance and aesthetics. Moderate to severe is serviceability or function, and very severe affects stability. So, this kind of gives you an idea of the categories of damage. So protective measures are usually required from damage category 3 or above, and that's where you start doing, more advanced analysis, both in XDisp and then possibly even 3D FE analysis. So this is from Berland's paper. This gives much more detail about, his categories of damage. XDisp will calculate the tensile strain on the building, and that connects to Berland's approximate crack width, which then connects to the cracks and the severity of damage. So he obtained this from observation, and this correlation is obtained from the elastic beam model, which I will go into in a little bit more detail. So this is available from our user manual as well. So please do have a look at it in more detail as to how the deflection itself is calculated and then how that connects to the beam calculation. So that is all available in the manual itself. So in terms of how we go about designing this as engineers, the real benchmark for and the first report that was really used and subsequently has been used for many projects is based on the Jubilee Line extension project. And what they did was they had three stages of assessment. The preliminary assessment basically looked at settlement contours, and where the settlement contours were too high or too close, so where you have a steep change in movement, there was a second stage of assessment where you do the building damage assessments, which is what XDisp will do for you. So in any of those areas where settlement was too high, for any of those specific buildings, you carry out a building damage assessment according to XDisp or the Berland categories of damage. And where those categories of damage were high, so possibly above moderate to severe, would do a detailed evaluation. So this is when you start looking at 3D FE analysis. So there are a number of assumptions this is based on. For example, I mentioned the elastic beam elements, but also that the structure is already in a reasonable state of repair. But all of this is covered in more detail in this particular guidance. So I do suggest you have a look at it in more detail. So for the preliminary assessment, you basically get the contours from a program from XDisp. So I would look at, for example, where the foundation is. I would put a grid in there. And in XDisp, I would find where the settlements were within a certain level. So the Jubilee line extension suggests that within 10 millimeters. So any buildings in this kind of red area, we would have to carry out a stage 2 assessment on. And if there was a higher slope, so 1 in 500 was the specification, I think, in the Jubilee line paper. So where those slopes are high, and the way you would assess that is you would put a displacement line in and look for a 1 in 500 slope. We would also carry out building damage assessments on those particular buildings. So this is all for existing buildings in these kind of danger zones. So you then go on to carry out the building damage assessment. So you would make the assumption that the building is effectively an elastic beam. You give a height for the building, and a program, XDisp itself will calculate for you whether the building is in sagging or hogging mode or a combination of everything. And generally, it is a combination of hogging and sagging. And then it will give you categories of damage for those sections of hogging and sagging. So this just gives you a little bit more detail, but that detail is also available in our user manual. So I might just touch upon that when we go into the program as well. So as you can see here, for this particular building, we have XDisp will calculate the strain, the movement, and the settlement, and then it splits that section up into sections of hogging and sagging. So as you can see here, we've got hogging sections here where we've got a positive strain, and you can see the settlement contours as well. Then we've got sagging and hogging again. So for one particular beam or one particular building, we will have, it will split, the program will split it up into sections of hogging and sagging. And when we go into the program again, I think I can explain this in a bit more detail, and hopefully it'll become a little bit clearer to you. So within the program itself, you get the tables and the tabular outputs, and it gives, for example, the damage categories for different sections, and that's within the beams. So for the different buildings, and for each specific building, you get an interaction chart as well. And because you get so many buildings, and often within the buildings you have different segments, we actually have a feature where you can output all of the charts and the results and the detailed results into a folder. So I'll go into the program as well and show you how to do that. Now, XDisp also has a feature that we were requested for infrastructure projects where, you might not necessarily want to analyze every single building in the danger zone. You might want to find areas, you know, of where we feel that the damage category is high. So we have something within XDisp called the generic building damage assessment. And the way that works is that you set up a polyline, and this polyline doesn't need to be straight. It could be curving, it could be quite large. And along those polylines, you say that, you know, across, you know, so many intersections of that polyline, I want you to carry out a building damage assessment. And using that feature, you can actually find out the area where you've got the worst case building damage. So that's what we call generic building damage assessment, because you're not really looking at specific buildings, but you're trying to find the worst case area of building damage. If you have any questions about that, let me know, but this is actually covered in much more detail in our tutorial manual as well, so I suggest you have a quick look at that if you're interested in trying to carry out the generic building damage assessment. Right, so that was building damage. I'm now going to cover very briefly utility damage. So based on your displacement line, you place a utility there. So it will give you your utility displacement, and you need to input in your utility dimensions, and XDisp will use that to calculate the strain, pull-out, and joint rotation of a pipe or a utility. You set the acceptance criteria for where the utility might fail or where there's a threshold, and whether the utility is fails or not is outputted in your tabular output, plotted in your graphs, and you can also show it in your graphical outputs. So that's all available to you. And again, when I go into the program, this will all become much clearer. There is a paper as well that was published in the DFI in Rome, and it goes through how XDisp is used to calculate utility damage. So I will try and make that link available with the recording of this video as well, because I think you all might find that quite useful. So again, as with the building damage, utility damage can be calculated in a generic manner. So if you don't have a specific utility, say, but you want to find out, you know, where certain utilities might be most in danger, you can do the generic utility damage assessment. So finally, we're going to go on to rail damage. So rail damage is one of our latest features. So rail damage will calculate the cant and the twist for a rail line. So cant is the difference of vertical ground movement between two rails. So this difference here, delta 1, take away delta 2. So this is the cant here. And then the twist is the difference in cant over here and there along a length of rail. So that's the calculation for twist. So hopefully this diagram is quite helpful. It is again in the user manual, so more detail about how it's calculated is there in the user manual. But if there's anything, you know, any questions you have, please do ask me at the end of this. But I will also be inputting in rail damage assessments in our setup, so hopefully that will help you understand how it works a little bit better. So in terms of other advanced features, XDisp allows you to incorporate PDisp settlements. And how this is helpful is that, for example, if you've got loading near your new excavation or new tunnel, maybe a contractor has told you, you know, they're placing a load or, you know, something near your excavation, you can actually consider that settlement and quickly add it into your XDisp analysis. So I'm going to show you how to do that today. But just very briefly, PDisp calculates the displacements due to the application of pressure. There's an elastic feature for PDisp and a consolidation feature as well. So for example, if you've got some construction surcharging, someone's putting in a flexible footing or raft nearby, you can assess due to that. Again, also unloading and loading. So if there's a demolition going on nearby, you can assess for that and do a building damage assessment due to that as well. So XDisp and PDisp combine, so you can get the PDisp results into XDisp and do a building utility and rail damage assessment on it, which is very useful. Another couple of features that I want to mention, which I might not have time to show you today, is that you can import a background DXF into XDisp. Now, you can imagine with the 3D outputs, this can be quite handy if you're showing you know, your results to a client, because it gives them context of where they are. Another thing is that you can actually import elements, so buildings, tunnels, and excavations from DXF. So this is a really handy tool again, and is quite popular. And finally, although it's not mentioned in the slide specifically, XDisp has really been developed extensively for API, COM, and automation. So we have a JSON file which can be generated with XDisp, and that can easily go into GIS and various other things as well. So if you're using big infrastructure projects, just get in touch with us because we can help you with that. Right, so I think it's time now to get into the program and show you how these different features work. So let me see if I can open up XDisp. So if you attended session 1, you might remember this particular file. So this is actually the file I set up in session 1. So there's an excavation here and a tunnel. There is a grid, just one grid in this case, a surface grid, which will give me settlements, and there are displacement lines. So this is the displacement data. You need to tell the program where you want to calculate displacements. So there's a grid set up here. And if you want to find out about how to set up a grid, again, watch session 1. There are a range of displacement lines as well. The only difference in this file to the file that I've set up is that I've actually taken this specific displacement line here, displacement line 3, and I've extended it down 5 meters below ground level to model my utility. But other than that, it's pretty much the same as it previously was. I've also changed the names of the lines so that I can follow better what I'm trying to do, because any assessment you do, be it building damage, utility damage, or rail damage assessment, you are referring back to displacement lines and polylines as well. So I've named the displacement line that I'm going to be using to represent my building as building. The displacement line I'm going to be using to represent my utility as utility. And I've put a rail line in there, but rail lines actually refer to polylines. So we'll go into that in a little more detail when we get to that point. So let's start with building damage assessment. And before I do that, I'm just going to save this because it's always good practice to save. So base file live. Okay, so let's save that now. Right. So I'm going to start with the building damage assessment. So we've got damage categories of strains. So we've got the Berlin strains in there, but I did mention that you can input your own strains in here. So if you're working with slightly different categories, you're using some empirical data, you're very welcome to save it in here, and it will save in the program. So I'm going to be focusing on specific building damage today. So if you look here, we've got specific building damage. So I'm going to input this in. So building, sub-building, I'm going to put the displacement line here as building. And this will give me the line length. So this is the length of that displacement line. So my building is going to extend the whole way along the line, but it might not necessarily do that in real life. So it's up to you how you want to do that. The vertical offset feature is really interesting. So for example, my displacement line is sitting at ground level. But say, for example, I want to carry out damage assessments at 2 basement levels. What I'm going to do is I'm going to say 0 here, and I'm going to have a vertical offset at minus 5.5 and minus 11, right? And then I'm going to use the limit sensitivities and everything here. So more detail about what these mean are in our user manual. But limit sensitivity limits the sensitivity to hogging and sagging. The damage category strains, I'm going to go with Berland. Poisson's ratio is a Poisson's ratio of the beam. The E over G value, which is Young's modulus over shear modulus, I'm going to go with 2.6. I'm going to say the height of my building is 10 meters. And I'm going to, this now, XDisp will calculate things like the second moment of area and various other things for you. So I'm going to say yes to the default properties. So that's the input of my building now. So I'm going to save that. And let's run the analysis and have a look at the results just for the building. Okay. So if I look at Output Explorer, let's look at that in 3D. So that's now, as you can see, a building is showing. And I can actually right click and look at the building properties specifically. So if I say, okay, I'm interested in apply. This will show me how my building's doing. So for one building, I mean, you can easily look in a table, but if you've got multiple buildings, this can be quite a strong feature. So as you can see for this building here, sitting effectively between a tunnel that's being inserted and an excavation here, a new excavation, there's a slight category of damage. So it's not hitting moderate or severe, but we might want to do a little bit more analysis on it according to the assessment criteria. But it's also interesting to look in more detail at the building itself. So let's have a look at the displacement. And as you can see, XDisp here has split up the sections of hogging and sagging. So it's showing you different segments within the building. So this displacement line represents the building. And then you can look at the building damage interaction. So as you can see here, we've got different segments and you can toggle between the segments. And there are different categories of damage for the different segments. So you can see here, there's no negligible damage for segment 3, but for segment 2, there's also negligible damage. And for segment 1, there's a little bit more damage. So this is where we're going from slight to moderate damage here. So these are the interaction charts, and they're quite helpful to be exported into reports and various other things as well. So I think that's covered the building damage assessment quite well. It does also cover the different offsets. So if I go down, let's have a look at what we're getting here. So this offset is at minus 11 meters. So this is more of a basement level. So as you can see, these are the categories of damage for that basement level as well. So the offset feature allows you to quickly look at different basement levels too. So that's quite an attractive feature. Okay, so that's the change in building damage assessments. I've deleted my results now because I'm going to input the utility damage assessment data here. So for utility damage, let's start with the dimensions. So for the internal diameter, let's go 1,200. Thickness 15 mil. So it all depends on your utility. For the acceptance criteria, in the gray here, we've got defaults, which are what we might typically use. I'm just going to work with the defaults here, but it really is very project dependent. So once you start with a project and you've set your defaults, you can change this yourself, say. So I might want to drop this limit, say, down to 200. And for the project, you can work with those defaults. So I think, every time you start a project, you need to decide the acceptance criteria based on, who you're working with. Are you working with, if I was working with London Underground, say, it would be very different to, if I was working in Singapore or Melbourne, working on the Melbourne Metro, say. So I'm just going to work with these defaults here. And there are also factors that you can change or apply. So that's fine with the acceptance criteria. So utility strain calculation. There's an option here to neglect the beneficial contribution of axial strains, but I'm not going to worry about that. So as I said, there's a generic utility feature, but I'm going to focus on specific utility. So let's go here. It's a jointed utility. There's an option to use a polyline as well. So for example, if you don't have a straight line, if your utility is curving, the polyline feature is quite useful. So I'll go for utility here. Right. Now, an interesting feature that's available in XDisp, as I mentioned, is that you don't need to go along the whole line. So my utility is actually, I'm going to go from 0 to 60 here, not the whole 110. And when I look at the plan, I can show you why. And I'll say it's a 5-meter pipe segment line. So if I look at the plan here, my utility is actually going not through the building. So my utility is pretty much, cut off here for whatever reason. So I'm just going to assess the utility between these 2 points here. So it just kind of showcases what that feature can do. So if I now check my inputs, right, that's fine. Save before analysis and run the analysis. Okay. So that means the results are all zero, means that at some point we're getting um, zero results for one of these particular stages, which means that we're not getting much strain or much rotation or something along those lines. So if I now look at the curves for the utilities, you can see that we are getting displacement along that utility and we're failing on rotation, but pull out and axial strain and flexural strain seem to be fine. Combined strain is also, you know, coming out beyond our threshold. Looking at all strains coming on beyond. And the radius of curvature is also quite high. So, you know, there are issues with this utility, and we need to look at some remedial measures to protect that utility. So if I look at this again in 3D, there's an option to actually show this. So this might be useful for a report or if you're in the middle of client meeting. So if I go to specific utility, I can actually here show whether it's, so in this case, you know, it's threshold, but it's not failed. Pull out is fine, but then you know, when if you remember, if we go to tension, it's not doing well. Compression is fine, but radius of curvature also, if I remember correctly, it was failing. So these are all, you know, little features that really help you to just, you know, show it in reports, put it in PowerPoint presentations, and, you know, it will help you then decide what you want to do. But as you can see here as well, it's not the whole displacement line that's working for that utility, it's only just this one section here. So hopefully that's really shown you what's available. So at this point, it might be worthwhile me showing you the feature of exporting the charts. So here, if you go to export and charts, you can actually choose to export all these charts and export the displacement data as well into a file. And it, you know, there's options that, you know, only for building damage, you know, less than a certain category. Again, utility and rail damage less than a certain, so it allows you to ignore charts which are less severe or ignore charts with values of zero. So if you've got so many utilities in so many buildings, this is a really powerful feature. And we talk about base model here, but actually the reason this is here is because you might have a number of stages. So, you know, if you do have a number of stages, this is even more helpful for you. So exporting charts is made much easier in Oasys XDisp with this particular feature. So we'll cancel that right now. So I think it just goes for me to I'm going to put this back in here. I'm docking this again. So I'm just going to show you now the rail damage assessment. So I'm going to again delete the analysis. And let's start with the rail damage assessment. So my rail track is along this specific line here. So if I look at my line, this is my rail line. But I need to refer to a polyline for the rail line. So let me set up the polyline first. So I'm going to just call it polyline 1. And the polyline starts from 20, 0, 100 and ends at 20, 110, 100. Okay. So if I then go to graphical input to check my inputs, I can see that the polyline is sitting there nicely. Okay, so that polyline is there. So now let's go and put the rail damage in assessment in there. So I'm going to again work with the defaults, but you might want to change those defaults for your particular project. And now the rail track assessment. So I'm going to put in polyline 1. It gives me the length, and my rail track is going to be sitting along the whole thing. So I'm just going to say 100. The track width, let's say 1.5. We'll work with the rail assessment criteria that we've been working with. Let's say the interval is 3, and the rail line is at the surface, so let's say surface, so it's fine. But it can work with underground rails as well, so subsurface. So let's now carry out our analysis. Super. And as you can see, we've got rail track assessments as well. So vertical displacements for the left and right rail, We've got cant, which is really not too bad. And we've got twist, which is near 0. So that's fine. The only thing I would like to say is that when it comes to rail damage assessment, so if you look at this rail here, it's really important that you actually look at the advancement of tunnels. So there are many cases where, for example, if I get this tunnel here and I make it longer and longer and longer, that's when this this rail will start to show more significant cant or twist. So you really do need to start using staged assessments if you're considering rail damage assessments. So you could use a program like XDisp Pro to do that, and we do advise it for infrastructure projects because it will save you a significant amount of time. But alternatively, what you can do is you can set multiple XDisp files up and then look at the damage assessment there, but that will take significantly more time. Right, so that's the rail damage assessment done. So that's all great, but I've now been told by my contractor on site that we're actually going to be loading around here during the construction. So I want to possibly assess what's going to happen with that loading. So I'm going to go into PDisp and apply that loading. So let's start by creating a new file. This is just an empty PDisp file. Now, PDisp and XDisp need to align in terms of their displacement grids and lines because you want to output the results in PDisp at the same points that XDisp is calculating them so that they can combine or align on top of each other. So what I'm going to do is I'm going to import from the XDisp file. So let's say open. I'm just going to import the displacement locations. I don't want to import the results, and the reason I don't want to do that, and I could have done that if I hadn't deleted the analysis results, is that if I import the displacement results, I'm double counting them. So please make sure you do click that off for the purposes of trying to get the results out and reanalyze them in XDisp. So I'm going to say OK to that. Okay, so you can see the displacement lines and grids are there. Perfect, right, that's fine. So what I'm going to do first is I have to put in some soil. So if you look at PDisp, you've got your analysis options here, and I'm just going to go with an elastic Boussinesq analysis. We do have a training webinar on PDisp available as well. So if you want to learn more about that, please do look at it. I'm going to look at the soil profiles. So if I input a soil profile in, I'll just keep it really simple. So I'll say layer 1 is at 100 meters. So that was where our surface level is. The displacement levels are where displacement calculated with a Young's modulus of 40. So remember, this is elastic analysis, so the Young's modulus and Poisson's ratio are pretty important. And overlaying that is that's overlaying layer 2, which is at, say, 85 meters. And let's give that a stronger, oops, forgot a 0 there. And let's do that again, 60,000. And again, 0.2. So that's given us now, as you can see, that's given us soil layers. We need to assess soil zones. So I'll use a graphical input features because it just saves so much time. So I'm just going to put the soil zones in there. Soil zone 1. So that's okay. So now we've given it basically values to calculate, but we haven't actually applied the load in there. So I'm going to put in a rectangular load to model my construction loading. So it's a horizontal load, centering at 110, 100. And remember the surface level was 100, so it's applied at the surface. It's not at an angle. Its width is 30, its length is 20, and it's a 50 kPa load that we've been given. Right, so now if I look again, I can just about, in the pink, you can see the load over there. So if I run this analysis, I should get some results out. Okay. So if I look at the plan, let me see that the results are what I'm expecting. Yeah, so I'm getting a displacement, a maximum displacement between 20 and 25 mil at the center of my loading, and that's going out. So Let's now combine this. So let's go to save this first. Save as PDisp webinar. Okay, so that's now saved. PDisp webinar. Great. So that's fine. So I'm now going to import these displacements. So if I delete, okay. Okay, that's fine. Okay, I don't need to import the displacement locations because that's already imported. It's in there. We used the XDisp results for that. So I'm just going to import the displacement results. So that means the displacements have been imported successfully. Super. So if I look, you can actually check the imported displacements as well. But if you look at these little gray crosses, it means that it's imported, and that's fine. So now if I run the full analysis and say OK, let's save this as well. If I now look at the results in plan, you should be able to see the differences. So let's have a look at that and see. So can you see now there's an excessive displacement here due to the loading. So if I look at the building damage interaction chart again, I can see actually it's not too bad. It's not affected my building too much, but it might have been the case. And then, we might have advised the contractor not to put that loading there. So, very quickly, um, within a minute or two, I was able to quickly check a construction query from site. So, these things are really handy in terms of combining the programs. So I think that's it for the demo today because we've already covered quite a bit. But if you do have any other questions, there is a lot of guidance on our user manual on how to import displacements and various other things. And actually, before I go out of that, I did mention that there's a lot of detail in the user manual about the methodology as well. So you can see the detailed calculations are available here. So you don't need to refer specifically to the papers, but there's also lots of input here about the programming interface, the API. I mentioned that specifically as well. Importing and exporting from things like JSON, and importing and exporting from CAD as well. So that's all available in the user manual. So do have a look at it. It's available free on the website, but you can also get it from the program by looking at the help section. So the XDisp help has a user manual as well as things like technical FAQs and emailing us if you've got any questions. Okay, so we know under the current circumstances that a lot of people are using XDisp from home. So we're getting a lot of queries on running the files and how to run them more successfully. We do advise you to run the analysis file locally, so not on a remote network. Save regularly as well, like I showed you I was doing today. There is a backup feature which you can access through tools and preferences, so we suggest you use that. Check that you're using the most recent build. So we fix the software regularly, and that is available from help about Oasys. To manage your license, for those using network licenses specifically, please use the license portal. More information about that is available on our website as well. So if you want more information about XDisp, I've mentioned the tutorial manual that's available from our website in the support section. I've looked at our user manual as well. There are tutorial videos. Previous webinars have gone through things like XDisp Pro and how to set up stages. It's gone through tips and tricks, and session 1 covered actually how to set up the tunnel and excavation problem and look at settlements. You can email support as well, and we provide training sessions. One other thing that I was asked to mention from the last webinar was that a lot of people were trying to trial the software. So if I go to our website, a trial is available, so you can request a trial by looking at the XDisp webpage and going to request a trial. But additionally, support is available. So if I go to support and look at XDisp, you can actually look here directly at getting the user manual, looking at the tutorial manual from XDisp documentation. So I do suggest you have a quick look at that as well. So user manual and tutorial manual are available to download from there. Right. So thank you very much for listening and attending. And I just wanted to cover what we've covered today. So we've introduced the assessment methodology in XDisp. We've showed you how XDisp would be used in a building damage assessment. The case study of the Copenhagen Metro actually also demonstrated this, and that was covered in session 1. So if you're interested in a specific case study of, settlement analysis and the different stages and assessments, please have a look at session 1. I've set up an analysis, and while I've been going through that, I've whizzed through some shortcuts and tips. I know I've gone through a lot very quickly, so a recording will be made available. So probably over the next day or two, we'll be sending you an email with a link to the recording as well, which you're very welcome to share with colleagues or upload onto your internal web pages for training for your colleagues. So thank you very much for your time today. Thank you for listening. And it just goes for me to say, are there any questions?